Welcome to The Foundry by Forge College. Let's jump right into this explainer on environment setup and readiness for Solana deployment. Now, if you're following along in the Deploying on Solana track, you know we're right in the middle of the Foundations of Pre-Deployment Checklist module. We're picking up exactly where we left off in our last lesson, which was identifying and mitigating risk management for Solana deployments. So, we're moving from identifying those scary deployment risks on a whiteboard to actually rolling up our sleeves and proving our environment is ready for the real deal.
Let's be honest, we've all heard, or maybe even used, the classic developer excuse. Well, it worked on my machine. And, it's pretty funny right up until your deployment spectacularly fails in production, and everyone is just staring at you waiting for a fix. That's exactly why hands-on, reproducible dependency checks are an absolute must. Sure, your risk mitigations might look like sheer genius on a spreadsheet, but if your deployment environment, whether that's an automated CI runner or just your teammate's laptop, can't actually execute them, they are literally just wishful thinking. We've got to bridge that massive canyon between theory and reality.
Here's our roadmap for today. First, the pre-deployment reality check. Second, building your checklist skeleton. Third, verifying core dependencies. Fourth, the network access test. Fifth, roles and responsibilities mapping. And finally, next steps for handoff.
Let's start with Section 1, the pre-deployment reality check. Building on what we talked about with risk management, we have to recognize the vast difference between theory and actionable verification. I mean, a safety plan on paper is completely useless if you can't verify that your continuous integration runner actually has the correct toolchain installed to execute it, right? It's kind of like designing a state-of-the-art security system for a bank, but never actually plugging it in to see if the alarms sound. You absolutely have to run real commands in the real environment to prove your setup works. Otherwise, you're basically just crossing your fingers and hoping for the best on deployment day, which is a terrible strategy. Moving right along to Section 2, building your checklist skeleton.
Go ahead and open your terminal. We are going to create the physical foundation of our engineering schematic. It's incredibly simple. Just make a directory, initialize Git, and create a scripts folder. But you might be wondering, why start here? Well, treating your checklist like a living codebase, tracked securely by version control, is where the magic of true accountability actually begins. No more floating sticky notes or unread Slack messages, okay? This is a hard, trackable record that grows right alongside your project.
Next up, you'll create a markdown file that acts as your flight pre-departure manifest. Think of a commercial pilot running through their checks before takeoff. They leave absolutely nothing to guesswork, no matter how many times they've flown that exact route. This establishes a simple, golden rule for your team. If a setup step, a verification command, or an ownership assignment isn't explicitly written down in this document under one of these headers, it simply doesn't exist. Period.
All right, Section 3, verifying core dependencies.
So, how do we actually prove our required tools exist? We definitely don't just politely ask people to install things, because, let's face it, humans forget and humans make mistakes. Instead, we automate the proof. We write a simple bash script to ping our tools, use standard commands to make it executable, and then have it dump the version info straight into our checklist. This removes human error entirely and creates an undeniable, automated snapshot of your environment's health at that exact moment in time. And what exactly are we capturing with this script? You are looking for semantic version strings. Those multi-part numbers like 1.16.0 or 1.70.0 for the Solana CLI, Node, Anchor, and your Rust toolchains. Seeing these hard numbers printed out guarantees that when deployment day finally arrives, you won't get hit with a terrifying command not found error that grinds the whole operation to a halt while everyone scrambles to install missing dependencies. Now, what if a tool is mysteriously missing? Don't panic and throw your computer out the window. Usually it's just a simple path misconfiguration, playing a really frustrating game of hide and seek with your tools. You can easily fix this by using the which command, like which Solana, to trace exactly where your machine is looking for the execution file. Once you find it, just add explicit installation and pathing steps to your CI image, and you've permanently fixed the gap. Section 4, the network access test.
Meet your absolute best friend for this step, the Solana test validator. Think of this as your isolated local sandbox. It's exactly like testing a firecracker inside a safe, controlled steel box before taking it out to a crowded park. It allows us to safely verify that your environment can boot up a node, check for sneaky port conflicts, and perform read-only verifications locally, all without relying on wonky external internet connections or live network states. It's a real lifesaver.
By running these exact terminal commands, you force the local system to wake up and give you a cluster version output. You're going to want to record this directly into your checklist, because this number is your undeniable proof of network readiness. If it fails, document the error, which honestly is usually just a pesky port conflict, fix it, and then rerun the script until you get that cluster version number. Remember, documenting the initial failure and the fix is just as important as documenting the eventual success.
Moving to Section 5, Roles and Responsibilities Mapping. As we emphasize in our other courses here at Forge College, a technical task without an explicitly assigned human owner is a task that simply won't get done. The absolutely crucial point here is mapping human accountability directly to specific mitigation steps from our original risk register. By mapping these specific IDs, anyone can see exactly which step belongs to the dev team, which belongs to DevOps, and exactly which theoretical risk mitigation it successfully satisfies out in the real world.
This traceability is an absolute game changer. It guarantees that if an environment check mysteriously fails at 2 a.m. on deployment night, there's no pointing fingers, no frantic Slack messages asking, "Wait, who owns this?" and no panicked confusion. A specific, named person knows exactly how to apply a fix and rerun the verification. It successfully turns what could be a chaotic, stress-inducing process into clear, highly accountable engineering.
And finally, Section 6, Next Steps for Handoff. Here is your gold standard for completion. A brand new reviewer, someone who knows absolutely nothing about your specific machine's setup, should be able to clone your repo, run your script, see the correct versions pop up, start the validator, and map those mitigation IDs completely unassisted. If they have to tap you on the shoulder to ask how a certain step works, well, your checklist simply isn't finished yet. It needs to be totally self-explanatory.
I absolutely love this principle. Start small and iterate. Why? Because an untested assumption buried deep in a massive, bloated deployment guide is a ticking time bomb just waiting to take down your main net launch. A partial checklist that is 100% accurate, tested, and verifiable is infinitely more valuable to your team than a massive, speculative wish list of things you merely hope will work. Accuracy always beats sheer volume when real stakes are on the line.
So ask yourself honestly as you wrap up this process, are your steps truly reproducible? Keeping your repository artifacts tightly committed ensures that any engineer on any machine can reproduce the exact outputs you just documented. This isn't just about passing a code review today. It's the solid bedrock of a scalable, stress-free deployment process for your entire team's future. It builds long-lasting trust across the whole engineering department, and that is priceless. That brings us to the ultimate question. When push comes to shove, will your carefully crafted checklist survive the intense scrutiny of final whitelisting and access control sign-offs, or will it crumble under real-world pressure? Think about how airtight your processes really are as we move deeper into this deploying on Solana track. Thanks for joining me on this explainer. Be sure to visit forge.college to learn more about this subject and other fascinating Web3 topics as we prepare for the final handoff in our next lesson. Keep building and stay accountable.